So hello viewers and subscribers, here is another video, sample problem video on sway frame solved by slope deflection equations. Actually, this problem was solved by slope deflection equations. So let's just solve this by slope deflection equation and be sure that the answers are the same to that of method of least work. So here's the given problem. A and D are fixed and this is a sway frame. I assume that the swaying is rightward so that the rotation of the chord AB and DC or CD would be clockwise because in the slope deflection equation, clockwise rotation, clockwise moments, positive. So that's an assumption. MAB therefore is 2 times EI 1 over L, 2 times 1, assume EI is 1, over L 8 times 2 theta near, 2 theta A is 0 because this is fixed, plus theta far, theta B, then minus, there is side sway, so minus 3 delta over L, 3 delta over 8. That's why delta is positive here. Then plus, there's no load on AB, so plus 0. So no fixed moments. So MAB is 0.25 theta B minus 3 over 32 delta. Let's call that equation 1. MBA, on the other hand, is 2 times 1 over 8 quantity 2 theta B plus theta A, which is 0, then minus 3 times delta over 8 plus 0 because there's no load. So it will give us 0.5 theta B minus 3 over 32 delta for fast formulation of the equation, especially if you are already familiar. You just interchange supposedly. One is double, the other is just half. So that's the equation. MBC is 2 times 1 over L, 2 EI over L, 2 times 1 over 6. Quantity 2 theta B plus theta C minus 3 times delta, which is, there's no side sway for BC. BC remains horizontal, so there's no upward or downward movement for BC. That's why there's no side sway, so it is 0 for BC. Then minus, because the fixed moment at B is negative, W36 square over 12, and that is negative 90. Simplifying, 2/3 state MBC, 2/3 theta B plus theta C over 3 minus 90. Then MCB, because the loading is symmetrical, you just interchange coefficients, theta B over 3 plus 2/3 theta C, then the fixed moment is the positive of 90 this time. Call that equation 4. MCD again has no load and the swaying is assumed rightward, so it is clockwise rotation. So 2 EI over L, 5, quantity 2 theta C, theta D is 0 because that's fixed, minus 3 delta over L, 3 positive delta over L because the rotation is clockwise. Length is 5. There's no load, so plus 0, no fixed moment. MCD is 0.8 theta C minus 6 delta over 25. Then MDC is, because this time it is theta D that is doubled, so 2 times 0 is 0, plus 2 times 1 times over 5 times theta C, so it is just 0.4 theta C or half of 0.8 theta C, then minus 6 delta over 25 also for the side sway part. Then we apply equilibrium at B. At B, MBA plus MBC equals 0. MBA is equal to 0.5 theta B minus 3 over 32 delta. Then MBC 2/3 theta B plus theta C over 3 minus 90. 0.5 plus 2/3 is 7 over 6 theta B. Then theta C over 3. Then minus 3 over 32 delta. Then this negative 90 here transposed to the right becomes positive 90. We then apply equilibrium equation for at joint C, MCB plus MCD equals 0. MCB is equation 4 and MCD is equation 5. Adding equations 4 and 5, we have theta b over 3. Then 2/3 theta c plus 0.8 theta c is 22 over 15 theta c. Then we copy negative 6 delta over 25. Then this positive 90 here to the right becomes negative 90. Then we need another equation because there are 3 unknowns in this equations here. So we need one more, and that is static summation forces x0. So I assume that AX and DX are all rightward to oppose the assumed clockwise moments at A, B, and C and D. So AX plus DX equals 0. Then we substitute the value of AX considering this free body diagram of AB, summation moment B equals 0. So AX times 8 equals MAB plus MBA. Therefore, AX is 1/8 of quantity MAB plus MBA. Then for free body diagram of CD, summation moment C equals 0. DX times 5 equals MDC plus MCD. So dx is 1/5 of MDC plus MCD. Substitute into this equation here, 1/8 of quantity MAB plus MBA plus 1/5 of quantity MDC plus MCD equals 0. Call that equation 40. Just call that equation 40. Then the LCD is 40. In other words, not equation 40, but rather we multiply everything by 40, the LCD of 8 and 5. So 40 times 1/8 is 5 quantity MAB plus MBA. 40 times 1/5 is 8 of quantity MDC plus MCD equals 0. Then this is 5. We substitute the values of MAB, MBA, MDC, and MCD from equations 1, 2, 5, and 6. So we have respectively. So we have 5 times MAB 0.25 theta b minus 3 over 32 delta, MBA 0.5 theta b minus 3 over 32 delta, plus 8 times MDC 0.4 theta c minus 6 over 25 delta, plus MCD 0.8 theta c minus 6 delta over 25 equals 0. Then combining theta b's, 0.25 theta b plus 0.5 theta b, 0.75 theta b times 5, that's 3.75 theta b. Then combining theta c, 0.4 theta c plus 0.8 theta c, that's 1.2 times 8, so that's 9.6 theta c. And combining deltas, negative 3 over 32 delta minus 3 over 32 delta times 5 plus 8 times quantity negative 6 over 25 delta minus 8 times negative 6 over 25 delta, or 8 times quantity negative 6 over 25 delta minus 6 over 25 delta. The total value is negative 1911 over 400 delta. Then equals 0. There are no constants here. So that's equation C. We can now solve these unknowns, theta b, theta c, and delta, considering the simultaneous solutions for A, B, and C using your calculator. So theta b is 96.341 over EI. Remember, there should be EI. Theta c is negative 105.612 over EI, and delta is negative 136.597 over EI. Because delta is negative, it means that this assumed sideway rightward is wrong and it should be in the left direction. But anyway, we just take the signs. So MA is MAB, and that's 0.25 of theta b minus 3 over 32 of delta. We can now compute MA, which is MAB, and that is positive 36.891 kilonewton meter. So it is clockwise as shown. MBA is 0.5 of theta B minus 3 over 32 delta, and that is 60.976 kilonewton meter. So that's clockwise also. MB is MBC, and it is the negative of MBA, so negative 60.976 kilonewton meter. MCD, substitute here, 0.8 theta C, then minus 6 over 25 delta it is negative 51.706 kilonewton meter mcd. Therefore, mcd is the negative of negative 51.706, so it is positive 51.706, so it is clockwise. MCB rather, clockwise, but MCD is negative, so it is counterclockwise. Then MDC, 0.4 theta C minus 6 over 25 of delta, negative 9.462 kilonewton meter, so it should be counterclockwise. But anyway, we just take signs. AX therefore is 1/8 of MAB plus MBA, so 12.233 kilonewtons. It's positive, so it is rightward. DX is 1/5 of MCD plus MDC, and it is negative 12.234. They must be equal. It should be leftward DX. But because of the rounding of values, there's a very, very small discrepancy which is tolerable and of course common sense. So it's correct. Then finally, share BC, summation moment C, considering this free body diagram, is share BC times 6 plus MCB, which is 51.706, equals MBC, which is 60.976 plus moment of the load 30 times 6 times 3. So that's why share BC equals, when transmitted to column AB, that's AY, and that's 91.545 kilonewtons. Then, similarly, summation moment B0, share CB times 6, then plus MBC, which is 60.976, equals MCB, which is 51.706, plus moment of the load 30 times 6 times 3. So shear CB can now be computed, and that's equal to dy, and the moments are already calculated. So that's it for this video. I hope that you were able to follow, understand, and enjoyed watching.